Hello, this video is a quick review of geometric shapes, some basic shapes that you're expected to know and what they look like and some of their properties. So let's get started. Basic geometric shapes that you will be asked to know and identify and draw and label and name. So all of these things are different. I know you know what draw means. Identify means tell me what it is. So if you see a picture of a point, you're going to write the word point. If I ask you to label it, you're going to label it with capital letters in the correct way. If I ask you to name the shapes, you're going to name them using the official way of naming the shape. So let's do a few. Okay? So first of all, a point. This is a point. So that's the picture, that's the drawing. What it's called, what the figure actually is a point. If I ask you to label it, you can label it with a capital letter like M. And if I ask you to name it, we would call that point M. I'm going to leave this one here because I want you to see that the name for this point, point M, is going to be different from the way we name the other things that I'm expecting you to name. So the next basic shape in geometry is a line. So a line in geometry is supposed to be straight. Of course, mine's not exactly straight because I'm drawing it freehand. But the important thing is that it has arrows on the end that indicate that it goes on forever. So this is called a line. That's identifying it. So if you see a picture like that, you would call that a line. Then when you label this line, you're going to pull 2 points out of the line. So we're going to specify those, and we're going to name them with a capital letter, each with a capital letter. So I might name that point D and that point R. And then, so that's labeling. And then the name of that line, the symbol for a line is a small line. And you write that above the letters D and R that you've pulled out of the line. Mine doesn't look very pretty because it's difficult for me to draw it. Okay, so you notice that this name right here, the name of my line, uses a symbol for a line instead of the word for the line. So drawing, label, what it's called, identifying it, and name. Same thing up here. Drawing is the dot, identifying it as the word point, putting a capital letter with it as the label, and its name is point M. Okay, we'll do another one on this page. Next we have a line segment. So line segments are like lines, except they can be measured because they don't go on forever. So again, mine's crooked, unfortunately, but this is called a line segment. Okay, and when I label the line segment, I'm always going to label the endpoints of the line segment. So I might call this point M and this point O. And the name of that line segment, I just draw a bar on the top, and this could be called line MO. Or excuse me, line segment MO. Okay, let me get rid of those. And the next basic measure is a ray. So a ray has an endpoint, and it goes on forever in one direction. So if it goes on forever, we have to put an arrow. This is called a ray in geometry. So we identify it as a ray. That's the drawing. To label it, we're going to pull out another point. We're going to label the end point. I might call that point P. And we'll call this point A. And then the name of the ray, this is important. The symbol for a ray, no matter what direction the ray goes, always points to the right. The end point always comes first. And then any other point on the ray to show what direction, where it starts and in what direction it goes. Okay? Next we have an angle. And an angle is the union of two rays. So we're drawing an angle now. Okay? And an angle is the union of two rays with a common endpoint. So two rays with a common endpoint. So here's one ray, and here's the endpoint, and here's another ray, and there's an end, and its endpoint is the same. Okay, so that's an angle. I would label my angle using the 3 points, C, A, and B. So the vertex, the point where the two rays are joined at the endpoint, and then 1 point on each ray. And I would call this angle. So this angle symbol looks like a less, sort of like a less than sign. Not very pretty. Let's try it again. Okay. So angle. And the important thing is that the vertex A is in the middle. Doesn't really matter what order I put the other one, so I could call it CAB or BAC, but this particular angle is called angle CAB. It doesn't go alphabetically. Okay, then we have 4 different kinds of measures. An acute of angles. Acute angles measure between 1 and 90 degrees. So if I asked you to draw an acute angle, you would draw one that looks something like this. And again, we got to make sure we put arrows on the end because it's made out of rays. A right angle measures exactly 90 degrees. So a right angle is drawn, it looks like a letter L with arrows on the end. And we put a little box in the middle of that to show that it is a right angle. And that's how I'm going to know that you've drawn a right angle. An obtuse angle. An obtuse angle measures between 90 and 180 degrees, so it might look something like this. With arrows on the end. Oops, my arrow got kind of funky, but that's okay. And finally, a straight angle basically looks like a line with one exception. And that one exception is that you have to have a vertex for your angle. So when you draw that, make sure you put the vertex somewhere on there. That's just going to be a point. Okay, next thing you need to know is that for complementary angles, the sum of their measures is 90 degrees. So if I ask you for the complement of an angle that measures 76, the complement measures 14 degrees because 14 plus 76 is 90 degrees. For supplementary angles, the sum of their measures is 180 degrees. So if I ask you for the supplement of that 76 degree angle, 180 minus 76 is 104. So the supplement is 104 degrees. Yeah, this is a degree sign up here. I kind of made it big, but I think you get the idea. Okay, moving on to polygons. You are going to be expected to know how to identify. Look at a picture and tell me what kind of a polygon it is. Or I may ask you to actually draw these polygons. Okay, so let's start with the triangles. All right, first kind of a triangle is an acute triangle. An acute, I'm just going to put an A there because I'm going to run out of room here. An acute triangle has 3 acute angles. 3 acute angles. Okay, so it might look something like this. That has 3 acute angles. A right triangle obviously has to have something about right, so a right triangle has to have a right angle, has one angle that measures 90 degrees. So we're going to draw our L angle, connect the ends, and then put our little box in there, and that'll show that we have a right triangle. And finally, an obtuse triangle has one obtuse angle. Can't have more than one obtuse angle. There's our obtuse angle right there. It's not right. I made that curvy. An obtuse triangle has one, oops, this is supposed to say 90 degrees, not 9, has one obtuse angle. One obtuse angle. Okay, let's erase that. Next we have isosceles triangle. So an isosceles triangle has two congruent sides. So an isosceles triangle might look like this. Boom, boom. And these two sides are congruent. We're going to note that by putting tick marks there. An equilateral triangle has three congruent sides. So if it has three congruent sides, we might draw it something like that. And that looks pretty close. But if we want to show that all three sides are congruent, we're going to put one tick mark on each side. And finally, a scalene has all different lengths of sides. So for most people, even though they're all supposed to be different, we have the hardest time drawing these. So usually when I draw a scalene triangle, I draw a right triangle because I can control better the lengths of my sides. But again, I can indicate that the sides are different lengths by putting a different number of tick marks in on all three sides. Then I know for sure, I'm telling people for sure, this has three different lengths of sides. Okay, next we have our quadrilaterals. So I think everybody knows what makes something a square. A square has four congruent sides. So we're going to put a tick mark on each side. And also has four right angles. Okay. A rectangle is like a square because it has four right angles. So we're going to put our four right angles there. But instead of all four sides being the same length, two of the sides, the ones that are opposite from each other, are the same length. And the other two are the same length, but they're not all four the same. Okay, next we have a parallelogram. A parallelogram looks like a tilty rectangle. What makes something a parallelogram is that the opposite sides are parallel. But because those opposite sides are parallel, the opposite sides are the same length. So I'm going to indicate that by putting the same number of tick marks on opposite sides. So I'm going to put two tick marks there, one there, and one there. A rhombus is a tilted square. Some people also feel that it looks like a diamond. The thing that makes it a tilted square is that all four sides are the same length. Okay. And finally, we have something called a trapezoid, which is a chopped off triangle. And a trapezoid has one set of parallel sides. And the other two are not parallel to one another. Oops, I couldn't get that to connect. Let's draw it up here. Boom, 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 boom. There's a trapezoid. Okay, then we have these special polygons. So what you need to know about these is the number of sides each one has. A pentagon has 5 sides. A hexagon has 6 sides. An octagon has 8 sides. And a decagon has 10 sides. A regular polygon has all congruent sides and all congruent angles. So a square is an example of a regular quadrilateral. An equilateral triangle is an example of a regular triangle. An equilateral triangle is an example of a regular triangle. Okay, I'm going to have to stop here. The time is about to run out. I'll continue on with the rest of this in another video. Good luck identifying them.